Greetings, Celebrate Galactic. For centuries, mankind has looked to the heavens and imagined traveling to space. Burt Rutan founded Scaled Composites Incorporated in 1982. Scaled Composites has been contracted by Virgin Galactic to create an aircraft that can take passengers on a suborbital path to view space. Scaled Composites have tested many prototypes and designs to create Model 339 Spaceship Two. The SS-2 is capable of carrying 6 passengers and 2 pilots. The seats of the passengers are positioned at a reclined angle to help offset some of the force during the launch. The cabin in which the passengers can move once in space is 12 feet by 7.5 feet. The span of the wings is 27 feet and the length from the nose to the tail is 60 feet. The aircraft stands 15 feet off the ground. The SS-2 is attached to a larger aircraft called the White Knight 2. The White Knight 2 carries the SS-2 to an altitude of approximately 1 mile. The SS-2 then detaches from the White Knight 2 and uses a single rocket that will propel the SS-2 to 68 miles above the Earth into the lower thermosphere. The SS-2 then detaches from White Knight 2 and uses a single rocket that will propel the SS-2 to 68 miles above the Earth into the lower thermosphere. From this height, the passengers aboard the SS-2 can see the curvature of the Earth and the darkness of space. The rocket is powerful enough to accelerate the SS-2 to supersonic speeds within 8 seconds of firing. The SS-2 contains enough fuel for the rocket to fire for approximately 1 minute. During re-entry, the SS-2 will fold its wings at a 90-degree angle to create drag, which slows the plane so it can re-enter the atmosphere at any angle, which is safer than the conventional heat shield covered spaceships. Safely re-entering the atmosphere, the SS-2 straightens out its wings to create lift. This allows the spaceship to safely glide to any runway. Changing the propulsion system will make the flight more efficient. I suggest changing the propulsion engine from a chemical reaction to an electrical propulsion system, specifically an ion engine. An ion engine contains a discharge similar to modern rockets. The discharge chamber is lined with magnetic rings used to create a magnetic field. The field is sent through an injector and a cathode. The back of the rocket is covered with a screen and an accelerator electrode. The final important part is a neutralizer. The ion engine uses electrons, neutral atoms, and positive ions to complete the propulsion cycle. The first neutral atoms are released along with the electrons and are caught in the magnetic field. The electrons and neutral atoms collide, causing ionization, leaving 2 electrons and 1 positive ion, which accelerates to the screen and then continues to accelerate away from the chamber with an electron which is released from the neutralizer. The process is then repeated. The velocity of gases leaving the exhaust to the amount of fuel used is 10 times greater than the velocity of gases propelling chemically propelled spacecraft. This would allow ion-powered flights to use less fuel. Thank you for taking time to watch my presentation on future space tourism, and happy space travels.